Hello, my name is Aiden McFall, and I'm a student with the North Idaho College Medical Laboratory Technology program, and today I'm going to be filming my Capstone project. And this particular project is exploring the Diagnostica Stago4 coagulation analyzer. And to explore this device, we're going to be using the PT test, or prothrombin time test, using citrated plasma to look at clotting time of a patient sample. I chose this particular piece of equipment because as a medical technologist in training, you are likely to encounter this piece of equipment as you begin to explore hemostasis. It's a semi-automated piece of equipment. It has 30 pre-programmed tests available to run in it that look at various aspects of hemostasis, including the APTT test, thrombin time test, rectalase time, lupus anticoagulant, protein C, protein S, and a variety of other possible players in the coagulation cascade of your patient. The PT assay in particular I chose because it's one of the first tests you're going to explore. It's one of the most ordered tests when a physician is concerned about hemostasis, and it is most often used to measure the effects of therapeutic doses of warfarin on patients who are prone to hypercoagulation. So today we will be discussing specimen type, transport, processing, storage, the reagents needed to perform the test, the procedures around the test, the reporting of results, and possible errors that you might encounter while performing the test. The specimen of choice for the Stago4 is citrated platelet-poor plasma from venipuncture. One of the key issues with that specimen is whether or not it was correctly collected. It needs to be collected into a blue-capped venipuncture tube fully so that you've attained a ratio of 9 parts whole blood to 1 part anticoagulant. So expired tubes are a source of pre-analytical error, as are rushed draws. You can't have a grossly hemolyzed sample, so extended tourniquet time or other traumatic issues have to be addressed during the actual venipuncture itself. And you want to make sure that you draw that blue top before you draw any tubes with additives, in particular the lavenders and greens with EDTA and heparin, and even gel-containing tubes are ordered after blue cap tubes to make sure that you have a great specimen for your coagulation assays. If your HCT is over 55%, your whole blood sample actually has a reduced amount of plasma in it, and you have to reduce the amount of sodium citrate in your collection tube in order to make sure that 9-to-1 ratio is attained. Mild hemolysis, icterus, and lipemia are not an issue for this particular device, according to the manufacturer's instructions. But you do want to make sure, in general, that you process your sample in a timely manner. There's variation here, but most SOPs require that you spin your sample within 30 minutes of collection and then remove the plasma, being careful not to disturb the buffy coat, and then finally freezing that plasma if you're not immediately taking into testing. Other labs are more lenient with their coagulation samples, allowing that whole blood blue cap tube to have a shelf life of 24 hours at room temperature prior to spinning and producing plasma that is used in testing. So individual lab SOP is important to check. One of the major pre-analytical sources of errors for hospitalized patients is collecting from a heparinized IV without adequately flushing it. Again, heparin at high levels will affect the PT assay, and heparin in general wants to be avoided if you're going to get high quality data from the PT coagulation test.